Hello, this is part 2 of SOA exam P problem 265, or at least it's a continuation of that problem. In part 1 we looked at taking a random sample of size 4 from integers 1 to 12 and then trying to find the probability mass function for the second smallest observation. And here we're going to do something very similar, but instead of sampling 4 integers without replacement, we're going to sample 4 integers with replacement. So we're going to put them back into the sampler, of integers 1 to 12. So the problem is 4 integers chosen with replacement from 1 to 12. Let x2 be the second smallest of a sample of size 4, right? Taking 4 integers. We want to find the probability mass function, or the probability that the second smallest observation is equal to x. X can only take on the numbers 1 through 12. And my personal thoughts is this is a great example or introduction into discrete order statistics. And I have a video called Discrete Order Statistics where we go into a little more depth and we're a little more general than what we'll do in this example. So here our data xi is discrete uniform from 1 to 12. That means the probability mass function is 1/12. The cumulative CDF function f of x is x over 12. And to do what we want to do, so to find this probability, we need to define 3 pieces of information. And initially it will not, you'll wonder why we're doing it, but it'll all come together. We're going to let P1 equal the probability that x, now that's a good point. So this x is from this, so it's from our discrete uniform. It doesn't have to do with the second smallest just yet. So the probability that x is strictly less than x is capital F minus little f of x, right? And it's x over 12 minus 1 over 12, which is x minus 1 over 12. And if you think about it, that, since it's discrete and it takes on integer values, you have to go to the one below it, and then it's a probability of being that, value. So it's like plugging in x minus 1 here, right? So the P2, we're going to define it as the probability that x is equal to x, and that's just the probability mass function f of x, which is 1/12. The P3, the probability that x is strictly greater than x, is 1 minus capital F, which is 12 minus x over 12. So now I want to give an illustration of finding this probability. The probability that x2 is less than some value x. And remember, this is a sample of size 4. And so the x with a 2 in the parentheses means it's the second smallest observation in our sample of 4 has to be strictly less than little x. So the illustration is this. So this is a number line, and here we're going to let 0 of our xi be greater than or equal to this value. So we've taken a sample of size 4, so we have x1, x2, x3, x4. Now that is different than putting a parenthesis around it. This is just our raw sample of size 4. And we're going to assume that 0 of our sample is greater than or equal to 4. So that means all of our data is less than x. So that means x2 has to be less than that, right? So x3 and 4 has to be strictly less than x, which then requires x2 to be less than that, right? Okay, it's kind of okay. Now, let's assume that we only have one xi greater than or equal to x. So x4 is here or more, and x3 is less than that. Well, that means x2 has to be less than x, right? If x3 is. Now let's go to let's assume that we have 2xi greater than or equal to x. That means, so if this is x and we have two values, only two values greater than or equal to x. So that means x2, the second smallest, has to be less than that, right? Now the question is, can we have 3xi greater than x? And the answer is no, we can't have 3. So let's assume we have 3 samples, 3 observations at x or more. That means there's 1 down below. So that means x2 has to be x or more. But we're looking at x2 strictly less than x. So we can't have 3xi greater than x when we're calculating this probability. So with that knowledge, the probability that our second smallest observation, so is less than x, is the probability that we have at most 2xi greater than or equal to x, right? Could be 0, could be 1, or could be 2. But the probability that xi is greater than or equal to x, that it becomes a binomial. We're either on it or above it, that's one category, or below it. So each observation fits into this or it fits into that. So that's a binomial. So the probability that at most is 2 is this. That we're going to sum from j equals 0 to 2. So and this is a binomial probability. So remember, P2 and P3 create a probability that we're greater than or equal to that little xi. So we have to sum those two probabilities. And P1 is the probability that we're strictly less than x. So if we plug in those values, then we can calculate this probability that x2 is strictly less than x. Now, the same logic that we did there, we can do for this one. The probability that x2 is less than or equal to x is the probability that at most 2xi are strictly above x. Okay, so the previous one we looked at x2 strictly less than x, and then that became an equal sign here. But in this one, we're looking at the probability that x2 is less than or equal to x, so at most 2xi are strictly above x. And we can plug those in. So to be strictly above x, it creates a binomial. P3 is the probability that we're strictly above x, and then P1 and P2 is the probability that we are less than or equal to x. And so this is a binomial that we sum, and we get this number or this quantity here. So to find the probability that x2, I should say, dang it. So the probability that x2 is equal to x is the probability of what we just looked. The probability that x2 is less than or equal to x, and the probability that x2 is strictly less than x, right? So we're picking off this, and that's the only thing left. But if we take the two polynomials that we calculated and expand them, we get this. And so this is the answer. So this is the probability that x2, our second smallest observation of 4, is equal to x, is this. And you can go through this and sum it from 1 to 12, and it does equal 1. So it is a probability mass function. But as a reminder from part 1, without replacement, we determined that the probability of the second smallest value is equal to x was this. And then if you expand this into a third order polynomial, we get this, right? And this also sums from sums to 1, if you sum it from 1 to 12. And if we were to look at the two plots of these functions, this is the without replacement. So this is the part 1 probability, or the probability mass function. And notice it's 0 at 1 and 0 at 11 and 12, as it should be. And for this one, there's a positive probability of being 1. And why is that? Well, if 2 of our observations are 1, then the second smallest has to be a 1. So there's a positive probability. Now here, as you come down, this probability is actually less than this probability. It's not symmetric. Well, how can the second smallest be a 12? That we have to have 3 observations at 12, and the other one can be anywhere. That means the second one is the second, the second smallest is a 12. Well, anyway, that's all I have for this video. Hopefully you enjoyed that, and it was informative, a brief introduction into discrete order statistics. Hope you liked it. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.